Welcome to clickmyproject.com.
It is our project title. Our project title name is STaRS, Simulating Taxi Ride Sharing at Scale. It is our project abstract. As the urban population grows, city faces the many challenges related to transportation, resource consumption, and the environment. Ride sharing has been proposed as an effective approach to reduce the traffic congestions and gas oil consumptions. And the population, however, despite the great promise, researchers and policy makers lack the adequate tool to access the traffic offers and benefit of the various ride sharing strategies. In our process, we propose the real-time data-driven simulation framework that support the efficient analysis of the taxi ride sharing. By modeling the taxi and trips as the distance entities, our framework is able to simulate a rich set of realistic scenarios. At the time, by provisioning the comparative set of the parameter, we are able to study the taxi ride sharing problem from the different angles and considering the different stakeholders interesting and constraint to the address of the computational complexity of the models. We describe the new optimizing algorithms. That is, the linear is the number of the trips and make uses for the efficient indexing the same, which combined with the parallelizations making our approach scalable. We evaluate our framework through a study that used the data about the 316 million strips taken from the 13,000 taxis in New York City during the 2011 to 2012. We describe the finding of the study, which demonstrate that our framework can provide the insight into the strategies for implementing the city-wide ride sharing solutions. We also carry one out of these details performing the analysis which shows an effective approach on DUE. The population and the cities now face the huge challenges related to the transportations. There are the substantial unused taxi capacity that can be filled by the ride sharing services. Consider over this translation the average accuracy of this 1,2 passenger per trip. The small percentage of the market, the wide deployment of the sharing recommends the better understanding in the trades-off. It is our project flow diagram. In our process flow diagram, the admin and the user, they are the two consumer, the two peoples are involving in our process. The user means the customer is an user. The admin can upload this data loading and pre-processing process. The admin can be load this whole of information about the traffic run of information and traveling information. It means the traveling means all of these places information and kilometer distance and the cost, overall cost to traveling cost. All information is including this process, this data. So the admin can be loaded for this data, and the next process is data pre-processing. The data pre-processing is used for this remove the garbage value collections. For example, the unrelevant of information can be removed for this field. For example, the null value data and unstructured and unwanted data. For example, the symbol representation. For example, semicolon, underscore, the question mark. This is all of the symbol representation. Unwanted symbol can be removing this data pre-processing. In this data pre-processing process can be completed. The data can be split into two types can be split. It is in DC1 means data clustering 1 and it is in data clustering n. The clustering process is a continuous process to cluster this cluster grouping the for based on the cost, area and street. This based grouping can be acquired. So data clustering 1 to n up to n process can be completed after the data can be passed for this HDFS, Hadoop distribution file system. The Hadoop distribution file system is one of the process. It can be used for this mapping and reducing technologies. After the map and reduce, the data can be passed from this data analysis. The data analysis mean it can be it can be gathered the complete analysis for this traveling time period and traveling cost and the traveling places all information. So it is a linear search means it gives this data for this analysis data can be passed for this linear search. The linear search mean it can be gives the priority order wise classification can be acquired. So it is in stack queue. Stack queue means it is in following this stack for which the user can be selected for source to destination. The stack queue gives the priority wise data can be passed for this passed for this information from the user. If the user can be selected for this another source to destination, when the data can be changed from the order wise. So it is in stack queue process. So it is in consumer. The consumer means the user. After the result can be viewed for this consumer. It is our project name STaRS. So it is our project homepage STaRS. So right click this run on Hadoop. So click this VMware server version and right click this finish. So it is our project homepage STaRS. Simulating tax rate share at scale. So click this image. So next process is an admin process. So it is an admin form can be opened. So it is an admin password admin 123. Sorry, admin 1 admin. So password is copy this paste 123. So user ID is 54321. So right click this login. So login successfully. The admin can be entered this process. The admin main process is uploading the file and pre-process the file and it can be send this file into the network server. So click this browse and choose this dataset. It is our project from the dataset. It is a traveling path. All information can be involved in this process. So it is in traffic and traveling route, traveling cost and a kilometer. All information can be involved in this dataset. So it is a dataset name, path and formation and it is in file size. So it is. So go to next. So it is in data pre-processing. So click this data pre-processing. So after the pre-processing can be completed, 139 pre-processed word can be removing this process. So it can be load data. So click this load data successfully. So after the load, the unwanted data can be removing this pre-processing process. So the it is in structured format data can be displayed this field. So it is an upload server process. First it can be goes to the server side and right click this run on Hadoop. So right click this and click this finish. If you click this run, it is in server side network receiver. The admin can be load and pre-process the data completely. So it can be sending this data from the network side. So it is in a data receiver. Data receiver can be gives this gateway number 444. I can give any number. But this receiver and the sender side number is same, the data can be transferred. If that's not, the error message can be displayed. I can be the 444. It is a data receiver, and I can click this data server number. It is also be a 444. So it is match. So the data can be received successfully. It is in data name and it is in data content. Can be displayed this field. So it is in goes to next. So it is an HDFS file systems and word count file system. If you click this HDFS file system, our the network can be load this file into the big data process. So success and our file can be successfully loaded for this big data. So the word count process can be completed. So if it goes to this VM location and it can be reconnect your VMware server. So if you can open this your files, it is a job can be created for this. It is our original data can be stored for this big data process. It is our original data can be stored for this big data. So it is a job can be created for each file systems. So after I can be goes to the clustering process. The clustering can be grouping it can be based on some attribute based grouping can be involved in this process. So data clustering can be completed. It is a very important data can be classify this field. So the unwanted means the non-relevant information can be removed. So this source, destination and the cost, address and the kilometer can be classified this and the field. And the next process is clustering 2. So it is also the unwanted and redundancy words can be removing these fields and clustering in grouping for this cluster. So second process, it is an real it is an structured and it is an complete data set can be data can be viewed as structured format. So after the user can be involved in this process, the user can be choose this which is source and which is destination. So I can be choose this Lagos and it is and goes. I can be choose this Shanghai. So I get goes to this Lagos and to Shanghai. Location source is Lagos and destination is Shanghai. So it is in latitude and location, latitude and longitude location can be displayed. It is in latitude location for this Shanghai. So submit. So after that I can be selected for source and destination. It is in source and destination field can be displayed. I can be location. So these types of path can be goes to travel from the Lagos to Shanghai. So it is in Lagos and this is Lagos to Shanghai. It is in a path for this traveling field. So it is in overall cost and kilometer can be displayed this field. Okay. So next process is on shortest. I can be classify this field to I can be classify this shortest, which is the best shortest path can be traveled from the this source to destination and click this. So it is a route of path turbine. So I can be goes travel to source to destination. I can be goes to the turbine. Traveling cost is 456. Total kilometers 297 and it is latitude and location. Okay, so I can be goes to travel from the I can be goes to travel to Lagos to so I can be goes to travel from the Lagos to Harbin and so it is I can be goes to Lagos to Harbin and I can be reached for the Shanghai. So it is in Harbin I can be travel to this and this. So the our total traveling cost and the kilometer can be less. Okay. So it is in for cost can be saved for users. So it is in Lagos to Harbin. Information can be displayed this. So it is in shortest path to I can be find this path can be shortest to traveling field. So it is in comparison graph can be displayed this final field. So it is in periodic Q. It is in periodic Q different mean the I can be find this shortest path. So the shortest to find can be very level can be various to find this level. So it is a level 1, level 2 can be periodic Q can be variation. And the next graph is an so it is in timeline variation graph and it is in sharing queue graph. So in this sharing queue the data can be shared from the one-to-one queuing model. So it is in time variation. In the time can be variation to finding the shortest field. So this information can be displayed this field. So thank you for watching this video.